Hi, everybody. Thank you for coming. We'll start on time, and hopefully we'll finish on time. So welcome to the session about electric vehicles. Now, within the rising prices of oil and with the need to reduce gas emissions, electric car sales are booming across Europe and beyond. Firefighters and ambulance services are facing new challenges, however. How to deal with electricity in case of accidents, how to deal with super hot batteries. As Director of Medical Services for the ambulance service in Greece, we have received bulletins from different electric car manufacturers about how to deal with each car, and all the details are exhausting. Electric vehicles are more and more used also by some emergency services across Europe. And the question is, do they present a viable alternative to thermic vehicles? How to deal with the need to regulate and regular and quick charging of those vehicles as well, but mostly what happens if an accident happens. I'm happy to have three colleagues to discuss the issue, and I'll start with Andy Baumann, Deputy Chief EMS Organization and Planning Division, Berlin Fire Department in Germany. And he has a very provocative title, Don't Be Afraid of Electricity.
Thank you. Andy, the floor is yours. Hello, everyone. I'm very pleased to show you our experiences. I have two parts in it. The first part is how to handle from our Berlin experiences, and the second is how we use electric fire engines and ambulances at the moment. So we have new challenges and we have recommendations in firefighting. And when you take a look at the news, of course, it's German news. So I'm not translating everything, but the summary is it's horrible. It's dangerous. The fire departments are not able to handle them. So, but it is true. And I have a question for you. Which of those two cars, one is electrical, one is conventional, is more dangerous? And we'll see the answer right now. Hopefully it starts. It did before when he tested it. That looks good. Not yet. Okay, there it goes. Okay, and as you can see, this red and yellow, that was not the electrical car. Of course, it was an ambulance, oxygen in it, so the answer is depends which of those cars is more dangerous. So, what is the challenge actually? This is a very old picture. There's also a very old car, and that was so easy. We opened the car, we put some water in it. Sometimes we even did not use breathing apparatus because it was not that much of smoke. And that was how we fought fires and car fires years ago. And now you see the different approach. You have to have full protective clothing. You need a lot of water, and you need additional information. Something we had before when we were fighting fires in planes or helicopters, that we need a detailed information where to put your hands on and where not. So, what are the challenges in dispatch? Since most of it here is about dispatch. We need, as soon as possible, all necessary information, license plate, type of car, and the access to that rescue data sheets. And for dispatch, if it's a known electrical fire, we need more units or units with more water. So, new challenges in fire suppression is extinguishing electrical car fires take longer compared to conventional cars. If the battery is ignited, there's a high possibility of reignitions on the battery. So smoldering parts are thrown over the area, flames coming out of ventilation openings, and the gas emissions, of course, and they always have been, gases have all been poisonous, but there are some flame explosive. So you need full personal protection. You still need the fire. And of course, stay away a little bit more far. You need to cool the battery if it's not affected yet, and you need tons of water for that, or you can consider special equipment. And if there are multiple cars, call for assistance as soon as possible. So that is some sort of additional equipment you can use. We have this. I haven't heard if we have it used except for training purposes yet. So also there are challenges in fire prevention. When they're in parking garages or anything else, we need early recognition of carbon monoxide and of hydrogen for gas and fire. We need sprinkler systems. We need an effective smoke and heat ventilation and to protect the building structure. And after the incident, that's also new, we need some sort of recovery. We have to turn off all the electricity. We have to control a longer time the battery temperature. We have to hand the whole place over to police or a salvage company, and we have to place the car in a quarantine area. That is also a new thing. But there's no need to drown every car into a container. So, Berlin experiences so far. Fires in electrical cars can be extinguished. Wow. So, in all Berlin fires with electrical cars, there's only one battery involved. If the battery is involved, you need a high amount of water, and you can even consider to let it burn out. The incidents are time-consuming compared to conventional fires, as I said. Again, no preventive drowning of the vehicle is needed. The battery gases are poisonous, and always move the vehicle to a quarantine location. And fire prevention has to do that job and do something more to prevent fires. So, we need better information for dispatch. We need standardized training material. We need additional equipment. We have to enhance regulations for fire prevention and vehicle recovery after fire. And we need the industry that makes standards for the identification of alternative engineered vehicles. We need standardized rescue data sheets. We need some sort of emergency shutdown, access opening for the batteries, and data access for battery management. So, and also we need more regulations for the recovery after a fire. So, that was the bad part. And now we have a good part, and we have our new fire engines here. That is a picture actually from 19-something, when all the fire engines in Berlin were electrical. So we are just reinventing new technologies. So what we have so far, we have a fire engine. I have no conflict of interest since I'm not buying any of those. What was the objective of buying an electrical engine? We want to reduce emissions, carbon dioxide, and noise. And this engine should be used in all situations, not only good weather, also catastrophes, and also with battery charging and less battery charging. Of course, also plan was to have better ergonomics because the engine is lower on the ground, so it's easier to put things out, and better driving safety. So that's the technical data. I will just not read it, but there are some insights. So that is for the driver, all the information. That is the additional equipment that can be in the cabin, and that's the cabin for the crew. Again, technical data, I will not do all this. That was driving tests, so that's the lighting system, and that's all the material stored. And as you can see, it's very low on the ground. The heavy parts are all low on the ground, so it's much easier for the personnel to put things out, especially the heavy ones. It works. It can also drive in some different areas. You can move the engine up and down a little bit, so it really is good. So, and the next thing this is a longer test, and we just started a new project, the EENA RTV, which means emergency ambulance. Again, it's a trial. We have a 6-month trial. Of course, we want to reduce emissions and noise. We want to test usability, better driving safety, and of course, patient transport. Again, some technical data. It's just brand new, this car, so I really cannot share any experiences. And the only thing where you will recognize that is an electrical car is in the front. Everything else is our standard ambulance, which we use on an everyday basis. So, our experiences with the engine, we had 99.5% of our calls were battery only. So overall 97, that was on the different stations. So I didn't mention that there's an addition to the battery, there's a diesel engine if there is a need for recharging the battery. So, experiences, electrical ambulances, none so far. The first day, the chief of the fire department tested it. He was happy with it, so we'll see. So what's the conclusions? E-mobility works for fire and EMS. With current technologies, it's probably easier to use in urban areas, especially for the ambulance, because range can be a problem if there are large distances to cover. We probably go for a mix of conventional and alternative vehicles, and of course, tests have to be continued. And that's about it. Thanks for listening.
Thank you. We have decided that we'll keep all questions at the end. So if you bear with us, we're going to go along with the second presenter, Sven Bruun, Senior Advisor, Department of Preparedness and Emergency Medical Services, Norwegian Directorate of Health. Experiences with electric emergency vehicles in the Norwegian ambulance service.
Thank you. Yeah, you have already introduced me, so I'm going straight to the first slide. I'm not actually working with the ambulance service, so these slides are based on input from the Oslo University Hospital, pre-hospital services. And I'm going to talk mainly about the ambulance service in Oslo, Norway, which is the capital of the country. They have 19 stations with 60 ambulances and 6 rapid response vehicles. And I'm mainly going to talk about them. They wanted to test out an electrical car in the service, and they decided to start with one of the rapid response vehicles, and are now going to add 3 more. They have not yet switched an ordinary ambulance to electricity, and I'll come back to that. And the criteria for this vehicle was that the car must handle various roads and terrains, plenty of room for the equipment, and fast charging. And the first car was delivered in 2019. And the car is only used during the daytime. It's not used during the night, so charging is not an issue for this type of resource. They selected the Audi e-tron, standard type, range 400 kilometers, and up to 150 kilowatt hours of charging speed. And the aim during the shift is to always keep the battery above 50% of charge. And as they say, you charge when you have the opportunity, the same as for ordinary users. And they have a charger installed at the station. And the equipment is standard for these type of cars. They have an emergency bags, multi-monitor, helmet rescue equipment, and personal protective equipment like this. And the driver's compartment is also quite standard. They have blue light switch panel. They have the ordinary map and mission system on screen. They have the access to the electronic patient record, and they have, of course, several Tetra radios. And before selecting this, they have the emergency instructors in the service to carry out thorough tests in various terrains, both in the woods like this, and also, of course, with snow and ice. And this was an important issue when selecting the car. And the experience so far, they have used separate checkouts for the personnel driving this car. They have positive feedback from the users. They have established good routines for charging, and the current usage is around 100 kilometers a day as an average. And of course, that's not an issue and a problem for this car. They are going to expand the usage of electric cars, starting with the administration fields. And they think that use of the electric ambulances will require better range, as also the previous speaker talked about. Other countries have started to use electric ambulances, as far as we know. Denmark have several, both this single responder and an ordinary ambulance, and also for the police. Sweden have bought their first electric ambulance, and also UK have a project with electric ambulances. Hydrogen might also be an option for the ambulance service, and the Helgeland Hospital Trust is located in northern Norway, and they have looked at hydrogen for use in ambulance and ambulance boats, actually, as an alternative to electricity because of the range. And they looked at the London Ambulance Service. They have one windshield like this, and are testing that one. But for Norway, they have considered that for them it is too early. It is too expensive and immature technology right now. Yeah, that's actually all I had to say. So thank you.